If he thinks it would have been fair if I tear out his pages and not yours.
I do understand that. I didn't follow just much, and I have to.
I don't have tape. Alright. Okay, relax. Right, so Botemelo asked for the effective resistance because they're in parallel with one another. We can't just say 6 plus 4 gives us 10. We have to say 1 over R parallel is 1 over 6 plus 1 over 4. That gives me 3, 5 over 12. Then R parallel is 12 over 5. Okay. And so the rest of yours is also wrong because you forgot to switch it. 10B? Because you forgot to use the wrong value. Yes, I know, but because this answer is wrong, B will be wrong, C will be wrong. C is right. I'll mark with a mistake, but that's why he struggled with B. But let me just see. Okay, so at question B, guys, shh, I can't focus. I am very easily distracted. Okay, so at B, they ask what is the total current that goes through the battery. So for that, I need the total volts and the total resistance. We just. 45.
So, ma'am, is it official that I'm going to bed for 3 hours?
You wanna write?
For 3 hours during the eclipse.
Where we're standing today, yes.
You mean it could change?
I highly doubt it will change. But with yeah, then you study for nothing. Okay, Botemelo. So they want the total current. For that you need the total volts and the total resistance. So the total resistance, we just got it to be 2.4. The total volts is 24. Okay, so you have Ohm's law. Ohm's law in words for a lollipop. Yes, Pukumuso. Then you must start. Yeah, Fatima. Okay, Bondle, go.
Okay, the potential difference across a conductor is directly proportional to the current through the conductor at a constant temperature.
Alright, Botemelo, are you? Then why was your memo open in front of you? Alright, Botemelo, sharp? Okay, are we done with question 10? Everyone good? Alright, question 11? What? I know, but my question is, does anyone have a problem with CD? Everyone that did their work, do they have a problem? Yes? Number 11. Alright, so at number 11, guys, I'm recording. Everything you're saying goes onto YouTube. It's true. Onto my channel. I think it's just my name. I don't know. Charlotte Marx. Charlotte is German. 65 subscribers. Yes. Okay. So we have cells, we have resistors in parallel, 8 and 4. And the volts there is 6 volts. Alright. Now they ask, what is the current through the 8 ohm resistor before the 4 ohm burns out and after? So something happens through the 4. Okay, so they want to know before it burns out, what is the current through that, and afterwards. Now, if we look at our current, then we see there it will split up. If we look at our sandwiches, we see that because there's nothing else, you either go to the 8 or to the 4. So you have 6 for the 8 and 6 for the 4. Alright, now I'm going to do a long method here because I want to make a certain point. Okay, before it burns out, I first want to consider the total circuit. You didn't have to do this, I just want to make a point, so you can add that to your answer. The total circuit. For that I need the total resistance and the total current, total volts. Total volts, easy peasy, is 6. Total resistance, I first have to do that parallel combination thingamajiggy. 16 to 6 over 16. Oh, I don't have to go to 16, I can just go to 8. It's 3 over 8. Okay. Then if I calculate the current is volts over resistance. I've swapped around my Ohm's law formula. Oh, really? But remember, at the beginning of the year, there was a consensus that even if the people strike or not, they're not allowed to influence the schools. Remember, there was that meeting.
But we struggle to school as scarcity. Yeah, because we don't have water.
Welcome to Parijs, so does the rest of the people. Wat sê jy? Ja.
They were hired to stay there.
Okay, kan ons aangaan? Dankie. Okay, so this is the total current in the circuit. So not the current that goes through the 8 ohms. It's the total current in the circuit. Now I want to get what is the current of that, how much of that goes to the 8 ohms. I'm going to use ratios. Okay, our ratio is 8 versus 4. Together that gives us 12. Now remember that current is inversely proportional to resistance. Okay, so if we want to get the current through the 8 ohm resistance, then we must look at the 4 over 12. We must look at the opposite. We must look at the crisscross. Okay, so we are going to say 4 over 12 of what? Of our total current, that 2.25. Have we started with our questions? Okay, so we're going to start here, 0.75. You should get the same answer. No. All right. So some of you just said, or most of you, I think, just said 6 divided by 8, and you get that answer. Yes? Perfectly fine. I said I'm doing the long way because I want to prove a point. I want to show you something. All right. Yes? Bukubuso, what do you want to say? Who can't see? Like because it's too far? or because of hair?
Come close.
Which?
I can see at the board. It's just that when you explain, I can't see because
Because of the hair.
Then, and if I can say, what if you moved a bit to the left, to the right? And then Karabu can just move a bit to the left. There we go. Better? Yeah, yoke. Alright, so then they tell us that the 4 ohm resistor burns out. Okay, so now our whole circuit changes. Now we do not have a parallel circuit anymore. Now we only have a series circuit. So now the total resistance is just 8. Okay, so the total resistance is now 8. This is now B. Okay, the total volts is 6. We want the current. So current is volts over resistance. And that is 6 divided by 8. And you get 0.75 amperes. Okay, now the answer is exactly the same. Still the same answers. Okay.
you use the Ohm's law for both A and B.
It's perfectly fine. But I want to prove why, or not prove, I want to say why did I show you all of this. What I want you to see is that when we add resistors in parallel, okay, so we add more and more and more resistors in parallel, then our total resistance decreases. Here our total resistance is 8. When we add something in parallel, the resistance actually decreases a lot. What happened to the total current? The total current increased. So when we decrease the resistance, the current increased. Okay, now this concept here, they ask a lot in a multiple choice question. That is why I did all of these calculations. Okay, they will ask, what happens to the current if you add another 2, 3 resistors in parallel? Then you have to say, the resistance decreased, so the current increased. Or they'll say, okay, you have this, now this resistor burns out. What happens? Okay, I'll get back to that just now. Okay, so when this burns out, what happens? The total resistance actually increased, so the current decreased. Okay, so this concept is important for you to understand. Okay, so I'm just going to say the opposite again. What happens when we add more resistors in parallel?
Current increase.
Oh, okay, wait. Thank you. So if we add more resistors in parallel, the total resistance actually decreases. Because we don't just add them together, we say 1 over, 1 over, 1 over. So the total resistance decreases, so the total current increases. Okay, so that concept you must understand, and that is why I did all of this. All right. Yes. Yes. Inversely proportional.
She wants to explain you. She wants you to explain like when one classes are
In parallel, then the total resistance decreases. What happens when you add more resistors in series? Well, the resistance will increase. Sharp. In parallel, in series, increase. Okay, back to your notes. We are at page... Oh, we're there. Okay, you guys are very behind the Afrikaans class. Like very.
Didn't see you yesterday.
I know, but they just don't make a lot of comments while I teach. Alright, so we are on page 5. 5? Okay, we first calculated the total current in the circuit because that's the reading on the ammeter. Now they ask, what is the current in each branch? So of that 5 men walking there, how many goes through? I think we said that was tourism, that was double science, that was business, I think. Alright, so, let's see. Let's take them one branch at a time. Let's first look at the 2 ohm branch. Okay, for the 2 ohm branch, what is the resistance, Karabu? What is the volts? Bukamuso. 6, because they're in parallel, so the volts will all be the same. What? Okay, so then we must get the current. I'm going to rearrange the formula. Current is volts over resistance. So the current is 6 divided by 2, and that gives you, Fatima? 3. 3 what? Amperes. Okay, so that means of our 5 men, 5, we don't really have 5, but of the 5, 3 choose to go through there. Does it make sense that 60%, the biggest chunk of our current, goes through the 2 ohm resistor? Why?
It's at least.
It's the smallest resistance, so it does make sense. Okay, now we're going to look at the Botomelu. Are we going to look at the 6 and the 6? Or are we going to look at the 12? We'll go. Because they're in series. So together, that whole branch is 12 ohms. Alright, now the volts is again 6. The resistance is 12. And that gives us 0.5 amperes. Does that make sense that the smallest amount, that 0.5 of our 5 goes there? Yes, because it's the biggest resistance. Now, without doing any calculation like that, what is the current through the 4 ohm resistor? No way. And that gives you what? Nia. 5 minus 3 gives you what? Minus a half. 5 minus 3 minus a half. Yes. Alright. So, wat het julle nou gesê?
Asking where does the 5 comes from.
Who asked that? The 5 or the 1.5? The 5 comes from here. That is the total current, and then the current splits up. A bit goes there, a bit goes there, and a bit goes there. Ja, ja. Ek lag net so lekker in die eksamen, né? Nee. Emotional. Okay, let's look here at the last bit of grade 10 work. We're not even at grade 11 work yet. Alright, here we go. 12 volts, 12 sandwiches. We see that everyone passes through that 4 ohm resistor, so the total current passes through there. And then the current splits up. A bit goes up and a bit goes down. Oh, will it split up into 3, Tazwar? Well, the current they split up into 2 or to 3? Hoekom nie 3 nie? The voltmeter's resistance is too high. It can't pass through there. Alright, and then we see everyone passes through that ammeter again. So that ammeter measures the total current. Then, Klonu, into how much must I divide my sandwiches? 2, 3, 4, 5? Hoekom?
Because the other one is in series.
Okay, so you have definitely one there that you should go to. And then you have a choice. Either that one or that one. But you can't go to both. Okay, so that is the other one. And we must remember that resistors in parallel have the same volts. Okay, right. Now they ask, calculate the reading on the ammeter in the circuit. Where's the ammeter? There's the ammeter. What does it measure? The total current. So at question 1, just FYI, you're going to need to draw in a lot of lines at the bottom. Or you're going to have to write next to one another. Your choice. Okay. Anyway, so we want the total current. For that, we need the total volts and the total resistance. Orifilwe, what is the total volts? Simpiwe. Total resistance. Can I just say 4 plus 6 gives me 10 plus 3 gives me 13. Hoekom nie? Because these two are in parallel with one another. You can't just add them normally. Alright, so we first have to do that 1 over r parallel. I'm going to zoom in. Is 1 over 3 plus 1 over 6. And that gives you 3 over 6. If you swap them around, you get 6 over 3 and that gives you 2 ohms. How do you know you're more or less on the correct path, Timkatso? 2 is smaller than 3, which is the smallest one in parallel. Okay, but that is not our total resistance because that is just the parallel combination together. Then we must still add that 4. Okay, so the total resistance is 2 plus 4 gives you 6 ohms. Right, then we're going to calculate our total current. Oopsie days. Current is volts over resistance. That is 12 divided by 6 and that gives you 2 amperes. Chop chop. Okay. That is the first question. Then the second question is, what is the reading on V1 and V2? So we want to know how much of our 12 volts goes this way, how much goes that way. Alright, so let's do that. Oopsie days. Alright. So question, what is it? B2. No, question 2. I'm first going to look at V1. Now V1 specifically gets the volts for the 4 ohm resistor. So my info table must fit with the 4 ohm resistor. So at my info table, my resistance is 4. My volts I want to get. And the current is 2. So why is it 2? Because okay, but there we calculated the total current. So I want you to say that the total current passes through the 4 ohm resistor. Okay, so we have resistance is volts over current. The resistance is 4. Volts we want to get. Current is 2. So our volts is, without a calculator, Bontle, 8 volts. Okay, so what does that mean for us? It means that of our 12 sandwiches, 12 volts energy, 8 is used there. So, sinomta, sinomta. How many volts will V2 read? 4. How did you get to 4? 1. So V2 will be 12 minus 8. That gives you 4 volts. You could have done a whole calculation or you could have just subtracted them. Okay. Then I'm going to go on here, but you can go on the bottom if you want to. Then they ask, calculate the current in the 6 and the 3 ohm resistors. Now, because there's 2 resistors in parallel, we can use ratios. So I want to practice using ratios. We have 3 and we have 6. Together they give us 9. So we have 3 over 9 and we have 6 over 9. Of what? They ask of the current. So we need to look at the total current that we got to be 2. So of 2 and of 2. Karabu. Nope. Nope. So 0, all right, and the other one? In your head, 2 minus 0.67.
It's 1.3.
All right, now you can see I didn't write amperes because if we use our common sense, we know that because this resistance is smaller, the bigger part of the current will go through there. So for the 3 ohm resistor, the bigger current will pass through that, not the smallest current. Okay, so we need to crisscross. So I'm going to write that down. I'm going to say the current through the 3 ohm resistor is 1.33 amperes. And the current through the 6 ohm resistor is 0.67 amperes. And I know you're going to forget this until the end of the year. So I want you to write down. I must remember that current is inversely proportional to resistance. Look at Oaks. So, what I want you to do for homework is, I just want to check something. I want you to do, on page 13, I want you to do the 1.10 and the 1.10. And on page 14, I just want to check here. I want you to do the whole 1.1. 11.1, sorry. I want you to do 11.2 until 11.2.2. 11.2.2. All right? Yes. But I'll make the same deal with you as I did with Afrikaans class. If Refu's team wins, then you only have to do the multiple choice questions. If they don't, then you do everything. Remember, you're going to have to do everything some point anyway.